Good morning, everyone. I'm Amanda.
And I am Cherry.
Today, we are going to present Krebs Cycle. Do you ever wonder what is Krebs Cycle?
Krebs cycle is a series of chemical reactions in aerobic respiration in which acetyl coenzyme A is completely degraded to carbon dioxide and water with the release of metabolic energy that is used to produce ATP. It is the second stage in aerobic respiration.
The Krebs cycle occurs in the matrix of mitochondria.
There are 8 steps in Krebs cycle. Before moving into the first step of Krebs cycle, this is the structure of acetyl coenzyme A, which is a product of link reaction.
The acetyl coenzyme A from the link reaction enters the Krebs cycle. The unstable bond attaching acetyl group to coenzyme A breaks. Thus, the acetyl group combines with oxaloacetate, forming citrate.
Step 2 is isomerization. Citrate is converted to its isomer, isocitrate, by removal of one water molecule and addition of one water molecule.
Step 3 is oxidation and decarboxylation. Isocitrate is oxidized and decarboxylated to alpha-ketoglutarate. NAD+ accepts hydrogen to be reduced to NADH and H+. CO2 is released.
Step 4 is decarboxylation and oxidation. Alpha-ketoglutarate undergoes decarboxylation, which means carbon dioxide is released. The resulting compound is oxidized. NAD+ is reduced to NADH and H+. The remaining molecule is attached to coenzyme A, forming succinyl-CoA by an unstable bond.
Next, step 5 is substrate-level phosphorylation. Succinyl-CoA will lose CoA, forming succinate. Phosphate is transferred into GDP, forming GTP. ADP receives phosphate group from GTP, forming ATP through substrate-level phosphorylation.
Step 6 is oxidation. When 2 hydrogen atoms is transferred to FAD, succinate is oxidized to fumarate. FAD is reduced to FADH.
Step 7 is addition of water. Addition of water molecule rearranges bonds in the substrate. Fumarate is converted to malate.
The last step is step 8, which is oxidation and regeneration of oxaloacetate. When 2 hydrogen atoms is transferred to NAD, malate is oxidized to oxaloacetate.